Hi guys, this is 3.3. We're talking about properties of functions when you graph them or when you're just looking at the equation. So a function can be either even or odd or neither even nor odd based on its symmetry. So symmetry is coming back, symmetry according to the x-axis, symmetry according to the y-axis, or symmetry with respect to the origin. Increasing functions, decreasing functions, and constant functions. Whether a function is positive, it exists above the x-axis, y equals 0, or negative, it exists below the x-axis, because the x-axis is y equals 0, it's the same line. And then, so increasing, decreasing, constant, positive, and negative, and then we're going to find local maximas, the high points, local minimas, absolute maximums, the highest point of the graph, absolute minimums, the lowest point of the graph. That's what we're doing. All right, so let us begin with even versus odd functions. If a function, so here we have three functions. If a function is even, let me mark them so that I can talk about them. If a function is an even function, the graph will be symmetric with respect to the y-axis. That means that f of a negative x is simplifies to equal f of x, right? For every point, and we already talked about symmetric with respect to the y-axis in the previous unit, for every point xy on the graph, the point negative xy is also on that graph, okay? Then we have odd functions. A function is odd if the graph is symmetric with respect to the origin. So there's no symmetric with respect to the x-axis here, okay? Just y-axis or the origin. So make sure you remember those from that previous lecture. If it is symmetric with respect to the origin, then f of negative x is going to be equal to negative f of x. Don't worry, we will practice this on the next slide, okay? For every point xy on the graph that is symmetric with respect to the origin, the point negative x, negative y is also on the graph. Finally, it could be neither, okay? If it's neither symmetric with respect to the y-axis nor symmetric with respect to the origin, it is neither even nor odd, okay? So first, notice that we are talking about functions. Remember that we learned that we use the vertical line test to determine if something is a function. So first of all, make sure A, B, and C all pass the vertical line test. Are they all functions? We don't have their equations, but we do have a picture of their graph. And if I do the vertical line test across A, I can see that it does not pass the vertical line test, right? A does not even pass the vertical line test. If it cannot pass the vertical line test, it is not a function. So it is neither an even function nor an odd function, okay? B passes the vertical line test. C passes the vertical line test. So now our next questions are, is it even, symmetric with respect to the y-axis, or is it odd, symmetric with respect to the origin? Okay, you can take your mirror and hold it up to the y-axis and say, are those the same? C certainly is not the same, right? Or what's the other? For every point xy on the graph, the point negative xy is also on the graph. So I'm just going to make up a point here, okay? I'm going to say that this is x negative 2, y2. All right, so for the point xy, negative xy is also on the graph. So this point has to be negative negative 2, which is a positive 2, 2. And I think it is. Those look to be the same 2 points. And maybe this is negative 4, negative 5, and then over here is positive 4, negative 5. So those look like we have symmetry with respect to the y-axis. So I would call this an even function. I can hold up a mirror, or I can fold it over on itself according to the y-axis, okay? This guy, with is it symmetric with respect to the origin? If we are doing one example of each, right, then this one should be symmetric with respect to the origin. So I'm going to pick the point. Don't pick the point at the origin. That one won't work, but let's pick a point far away from the origin. So maybe this is x equals, I'm going to say 4, because I guess that's how many I drew. So this is the point 4, 1. So if this is the point -4, -1, then that means every point x, y, the point -x, -y is also on the graph. This is the point 1, 1. So over here would be the point -1, -1. So that looks to be an odd function. For this one, we hold up the mirror. For this one, what I do is I take another piece of paper, I draw the function, and make sure you draw where it happens. Does it happen through the origin? Then I take, if it's on paper, if it's possible, or you can take your paper itself and flip it over, and I make sure that that still looks like the same graph. It should be the same graph upside down if it has symmetry with respect to the origin. So it looks like it does. So for this one, we'll talk about it later, but f of -x is the same as f of x. So when I substitute x for -x, I get the same answer. If it's odd, then when I substitute -x in for x, it makes the entire equation into the negative version of itself. Good? Okay. So for practice, determine whether each of the following functions is even, odd, or neither. Then verify using a graphing utility. So what we want to do is remember the two rules. The two rules are, is it over here? The two rules are, if it's even, f of -x will equal f of x. So I'm going to write that down. If it is an even function, then when I change x to -x, my answer is going to be the same as the original answer. If it is an odd function, when I change x to -x, the entire function becomes negative, the negative version of itself. So if it's even, -x does not change the equation. And if it's odd, a -x in place of a positive x makes the entire equation, or the entire function, negative. Okay, so that's the even one, that's the odd one. And what I need to do is I need to change, for each example, change my x to -x. And I'm even going to put parentheses around them. Change x to -x. Good? A is f of x equals 2x squared plus 3. What do I need to do? Change x to -x. So now 2x squared is 2 times -x squared plus 3. -x squared means -x times -x. -x times -x is just x squared, because a negative times a negative becomes a positive. So once I simplify it as much as I can, I see that it is the same. It is an even function. I put in a -x, but I got the same function I started with. So we're going to call this one even. That is even. Okay. If it's even, it's going to look like 2x squared plus 3. If it's odd, what would have happened? If it was odd, it would have become all the way negative. So negative would have been a negative 2x squared plus 3. When I distribute that negative sign, it would have been negative 2x squared minus 3. Okay, so that's what I need to see if it's an odd function. That's what I need to see if it's an even function after I simplify it. And if it's neither of those, we just say it's neither even nor odd. So we're going to call this one even. All right, B, let's look at B. So B is g of x equals x cubed plus 3. So let's just talk about what we want to see. Sorry, never straight enough, never in focus enough. If it's even, what do we want to see? If it's even, we just want to see that exact same equation back, x to the third plus 3. If it's odd, I expect to see a negative version of f of x. So negative x to the third plus 3, which will eventually look like negative x to the third minus 3. Okay? So let's do it. Again, all we do is we take my x and we take our x and turn it into a negative x. So instead of x to the third plus 3, we have negative x to the third plus 3. What does that mean? That means negative x times negative x times negative x plus 3, right? Negative x times negative x, we know, makes x squared. So I'm going to call that x squared times a negative x plus 3. When I have an x squared times a negative x, I'm basically multiplying a negative x times a positive x, so it's going to become a negative x, and then that's the same base. The signs are different, but this base is the same. So x squared and x to the first is going to be x to the third, right? 2 plus 1 is 3, plus 3. So when I look at my final answer, g of x equals negative x to the third plus 3, it is not even because that x to the third became a negative, but it's also not odd because the positive 3 did not become a negative 3. So this one is neither. Good? Okay. C asks us to do h of x equals x to the third plus 4x. So it looks a little bit like this one, right? But there's an extra x here. So if it's even, it's going to be the same. So even is going to remain x to the third plus 4x. Odd is going to be negative x to the third plus 4x. When I distribute that negative, it's negative x to the third minus 4x. Good? Okay, so we have x to the third, but I'm going to call it negative, because I'm substituting in a negative, negative x to the third plus 4 times negative x. So now this might be odd because instead of keeping the 3 positive, now the 4 is going to become negative because that x became negative. So negative x to the third we know comes out to be negative x to the third. And then a 4 times a negative x is a minus 4x. And so that is odd. We have an even, a neither, and an odd. And then our last example, did not leave much room for it, but I'll start over here. Our last example is capital F of x, I don't know why, but I really don't like those capitals, equals 1 over x squared plus 8. So this looks a little different, but again, all we're doing is we're substituting a negative x in for the x. So if our answer is even, we want to see the exact same thing. We want to see 1 over x squared plus 8. If it is odd, we want to see negative 1 over x squared plus 8. Good? All right, so let's write this again with a negative x. 1 over negative x squared plus 8. Negative x squared is just negative x times negative x. Negative x times a negative x is a positive x squared because a negative times a negative becomes a positive. So what we end up with is the even version. We can put in a negative x, but it does not change f of x. Good? So that's how you determine whether they are even, odd, or neither. We said A was even, B was neither, C was odd, and D was even. So we change x to negative x. If it remains the same equation, it's an even. If it becomes exactly the opposite, it is an odd. And if it's something in between, we call it neither, okay? All right, so let's now talk about increasing, decreasing, and constant functions. When we are talking about increasing, decreasing, and constant, we are talking about the slope of the function, okay? So from f of x1 to f of x2. That sounds confusing, but what they mean is from here to here. If you can see it on your paper, it's x sub 1, x sub 2, x sub 1, x sub 2, x sub 1, x sub 2. So those are your two x values, the x of 0.1, the x of 0.2, the x of 0.1, the x of 0.2, the x of 0.1, the x of 0.2. And so this would be your y value of 0.1, your y value of 0.2, y value of 0.1, y value of 0.2, y value of 0.1, y value of 0.2. So when you're graphing those, the coordinate point is just x, f of x, instead of xy. Okay, so you're increasing, decreasing, and constant from f of x 1 to f of x sub 2, from here to here. All right, a function is increasing on an interval if the graph continuously rises from left to right on the entire interval. That's an increasing function, okay? A function is decreasing on an interval if the graph continuously falls from left to right for the entire interval. And then a function is constant on the interval if it remains at a constant height from left to right for the entire interval. This one is increasing, this one's decreasing, this one's constant, okay? The way you would write it is from and including x1 to and including x2, it is increasing. If you want to relate it back to slope, it has a positive slope. Okay? Here, between and including x1 until and including x2, it is decreasing. It has a negative slope. You should definitely feel comfortable with slope. Negative slope. Good. And then here, from x sub 1 to x sub 2, it is going to be constant. And I want to just make clear what I mean by x sub 1, x sub 2. Maybe this is the point 1 and this is the point 7. So we would say from 1 to 7 included, it's increasing. From, maybe this is 5, and maybe this is 8, right? So from 5 to 8, it is decreasing. So that's the point 1, 0, and that's the point, what did I say, 7, 0? So here's the point, maybe x equals 2. So we don't know what that point is, but this point is 2, 0, and this point is 5, 0. So it's from 2 to 5 included, it's constant. And that obviously isn't the same as the actual point. The actual point is going to be maybe, this one will be 5, 4, and then this one will be 8, 2, right? We're not talking about the actual points, but just on the x-axis, this is 5 and 8. So between 5 and 8, we're decreasing. This is 1 on the x-axis, this is 7. So between 1 and 7, we're increasing. But this point would actually be 1, 4, and then that one would be 7, 8. This one would be 2, 3, and then that one would be 5, 3, because it stayed constant. All right, so determine the intervals for the most complicated part of this. I just want to communicate is the writing the intervals correctly. So that's what I was trying to do with that second part. Determine the intervals for which the function is increasing, decreasing, and constant. Okay, so we said increasing was purple, decreasing was green, and constant was, no, sorry, I didn't. Increasing, decreasing, whatever. It's changed. I've changed it. Too late. Okay, so look at your graph. Look very carefully at your graph. It doesn't start at -2, it starts at -4. So we are beginning at -4 and ending at 4. How are they going to let you know where it begins and ends? They are going to say the interval -4, 4. Okay, that means we're starting at -4 and we're going to 4 on the x-axis. Okay, so now you're just going to label increasing, we said was purple, decreasing, we know what that looks like. Decreasing means it's going down. Okay, and constant means it's flat. It's hard to see, but -4 to -2 is constant. What's this one? Oh, that one's going up. So that's another increasing, okay? So we have 3 different categories. We have increasing, we have decreasing, and we have constant. Okay, I'm going to start with constant because it's the only one where there's only one part that's constant. So it is constant including and beginning at -4 until and including -2. Done. That's the only spot where it's constant. Okay. We include because from here to here, it just stayed flat. Okay. Increasing is going to be from -2 to 0. You're not looking at y, you're only looking at x. So it's increasing from -2 to 0, and then it's increasing again from +3 to +4. So from +3 to +4, it's also increasing. So where x equals -2 to x equals 0, it's increasing. Oh, sorry, you couldn't see that. And then from x equals 3 to x equals 4, it's also increasing. From -2 to 0 and from 3 to 4. Okay, they might ask you for a comma, they might ask you for union, the U symbol. All right, decreasing. Where is it going down? Oh, that's only 1, 2. So it's decreasing from 0 to 3. Right? Why are these all included? Because if you take the true point 0, it's at 0, 2, and then 0.00001, it's going to be going down from there. So decreasing is like a verb, and even though it's a point, it's already going down. As we move away from that point, we're going to go down. So from that very first point down, it's decreasing, but this way it's increasing. So it can be included in both increasing and decreasing at the same time because it's compared to what? All right? So that's why we always use brackets for increasing, decreasing, and constant. However, there are 2 other questions they ask. They ask, where is it positive? And alternately, where is it negative? Where is it positive and where is it negative? Positive and negative means above the x-axis and below the x-axis. So remember, this was a positive slope. This was a 0 slope. This was a negative slope. And we covered that, right? We went all the way from -4 to +4. -4 to +4, we covered all of it. But now where is it positive above the x-axis? So by positive here, they mean above the x-axis. And by negative, they mean below the x-axis. Totally different question, okay? So when we look, negative is this part. And I know I'm messing up what we already did. But negative is from two to 4. It went below the x-axis, okay? Positive from -2 to 2, it was above the x-axis. So that's what they mean by positive and negative. So when we say positive, it's not going to include the -2 because at -2, we're at 0. 0 is not above the x-axis. 0 is at the x-axis. So -2, but not including, so parentheses, up to +2. Don't stop just at 0. It's still above the x-axis until we get back to 0, right? And then negative means below the x-axis. It's below the x-axis from 2 to 4. It touches the x-axis at 2, 0. It touches the x-axis at 4, 0, but it's below it everywhere in between. So that's what they mean by positive and negative. It's a lot to ask from one picture, but I think we've got it, okay? To make it more clear, here's my x-axis. My x-axis is just y equals 0. If my graph is below it, then we're negative. If we are above it, then we are positive. And then we know the rest of it, right? We know that this is increasing, that's decreasing, that's constant, that's positive, that's negative. Totally different questions. But they'll show up on the same question. Let's now talk about local maximum and minimum. So the local maximum is higher than all the other points, the top of any hill. Okay? A local minimum the bottom of any valley. And so here are two pictures, okay? Here is a local maximum, here is a local minimum. Okay? What I want you to understand about local maximum, the top of a hill. It goes up, comes back down. Up, comes back down. What I want you to know about a valley is a valley goes down, comes back up. Okay? When we are talking about what is the local maximum is C, comma, FC. That is our local maximum. Our local minimum is C, comma, FC. Okay, that is the XY value that is highest. We went up, we came back down, but that was the highest point. We went down, we came back up, but that was the lowest point. Got it? Another very important thing is anytime you see something like this, it's a hole in the graph. So that point, that does not exist in the equation. Does not exist on the graph. That XY value is not a solution to the to the function. So if that is hollowed in, it's a point on the graph. If it's empty, it's a hole in the graph. It's not on the graph. Not included on the graph, not a solution to the function, not included in the graph of the function. So when you're looking for local minimum, if you have a C, comma, FC, but it's hollow, that's not going to be your local minimum. So let's locate any maximum values, but make sure we acknowledge that it's a local max. Let's try to actually keep the colors going. Local max, already forgot, green. Local minimum. Okay? So a local maximum is a hill. A local minimum is a valley. It has to go up and come back down. It has to go down and come back up. This, regardless of whether it's an arrow or not, it's not a local maximum because it doesn't come back down. Okay? So our only local maxima is this point. They give us the point 0, 3. So that's one way to write it. But you can also write it as, okay? So for A, they're going to ask you to write it as local maxima is f of 0 equals 3, or at x equals 0, the local maxima is is 3, okay? That's more likely how they'll ask you to write it. Same answer, 0, 3, 0, 3, 3 when x is equal to 0. Good? Okay, if you feel comfortable with, as long as you feel comfortable with x, f of x, or more creatively, what they called it was c, f of c, you'll be able to translate that pretty simply. But if this is still looks a little bit weird to you, that's why this, it would follow that this would be also a bit foreign. So locate any local minimum values. So you want the lowest point, okay? It's a valley. It's there. You don't just have to have one, you're allowed to have two. I see one valley here and one valley here, okay? So we can say that there are two local minimums. It's the lowest point of the area, right? Your local. -2, -1, and 1, 0. Those are both local minimum values. So local minima, I think. Local minima. No, local maxima. Local minima, okay. Is f of, so your first one is 0, f of x is y, okay? At x equals, which one's x? Which one's x? My -2 is x. At x equals -2, the local minimum is -1. I think it's supposed to be maximum, because that's a plural. I don't know. Thank goodness. Goodness, it's not English class. Good. And then there's second local minimum is local minimum is, I want you to try to do it, okay? Pause the video and try to do it, is f of -1 is 0. F of x is equal to y, okay? At x equals, which one's x? The x is 1. The local minimum is 0. How low is it? It's 2, 0 on the y, okay? It's at this point, but it went down to 0. It's at this point, but it went down to -1, okay? C, identify the interval on which f is increasing and decreasing. Increasing means the slope is positive. So it's positive here, and believe it or not, even though the arrow's pointing up, this is not increasing, okay? That's actually decreasing. We just want to look at it like you're reading a sentence, like you're running into the line. If you run into this line, you go downhill. So that's decreasing. I reused the same color, I'm sorry, I hate it. So those sides are decreasing because left to right, that's going down, left to right, that's going up, left to right, that's going down, left to right, that's going up. That's how I decide, okay? So we are increasing. We only want your x values, okay? Where are we increasing? From x equals -2 until x equals 0. Then again, we will start increasing at 1 until infinity. You can do that, okay? It might ask for a comma, it might ask for the U symbol. I should have checked, I'm sorry. And then let's do decreasing. It's going to be decreasing from -infinity until x equals -2, right? You can include -2 in decreasing and in increasing because we're comparing it on this side, it's decreasing, on this side, it's increasing, so that's okay. It's either a union or a comma, and from x equals 0 to x equals 1. And then you see a pattern. From -infinity to -2, it's decreasing. From -2 to 0, it's increasing. From 0 to 1, it's decreasing. And from 1 to infinity, it's increasing. So we've covered all of it. Kind of the hardest part is notation. Absolute, minimum, and maximum. Any point higher than all points is absolute. The absolute maximum is the highest point. Okay? The absolute minimum is the lowest point. Good? There can only be one. Remember, for local minimums, sorry, that was my paper. For local minimums, you can have more than one. That one was a local minimum, that one's a local minimum. Absolute, only one. There's only one highest point. Okay? It's not going to be an arrow. If you just have an arrow going up infinity, that's not the absolute maximum or the absolute minimum, because that's just the number infinity. Okay? So here we have a comma f of a, u comma f of u, y equals f, oh, sorry, that's just the line, y equals f of x, b comma f of b, v comma v of f of v. Oh my goodness. Got it? So those are each of our points. This is the point A on the x-axis, right? X equals A, X equals U, X equals V, X equals B, right? Our absolute maximum, the highest point on the graph, is U f of U. Okay, that's our absolute max. Our absolute minimum is going to be the lowest point on the graph. So our absolute minimum is going to be V f of V. Incidentally, because they need to be hills and valleys, this is also a local max. And this is also a local min. So you can be both a local min and an absolute minimum. You can be a local maximum and the absolute maximum. Okay? So for 5, we're just going to go through, find local and absolute maximum and minimum values. Okay? So 4, I guess I need to label these A, B, C, D, and E. Yeah? So for letter A, let's talk about this, okay? 3 is my X, 6 is my Y, but the way we've been talking about it since we've started functions is X, comma, f of X. That is the same as XY, all right? So here my X is 3, my Y is 6, my X is 1, my Y is 3, my X is 5, my Y is 2. My local max. What is the highest point that still comes down? It's going to be 3, 6, right? But I want to answer it the way that they're most likely going to ask it, which is it's equal to 3 and it is at 6. X is 3, my height is 6. It locally goes up to 6, okay? My local minimum, it has to be a valley. It has to go down and come back up. So it's going to be X is 1 at 3, okay? Separately, absolute max. My absolute max, very highest point doesn't have to be a hill, can just be a single point, but does have to be the highest point. It's going to be the same one. X is 3 at 6. Absolute min, the lowest point, it doesn't have to be a valley, so it can be 5 too. X equals 5 at 2. Okay? We can also answer that as my local max is, so just to be clear, f of 3 is 6, f of 1 is 3, f of 3 is 6, f of 5 is 2. F of x equals y. Good? F of x equals y. B, my local maximum, remember, if it's hollowed out, that is not a point on the graph, so we're just going to say there is none. Local minimum for B, it has to be a valley. It has to go down and come back up. So that would actually be the absolute minimum, and that is nothing. But that cannot be a local minimum because it doesn't truly follow a valley. It doesn't go down and come back up. So there is no local minimum, okay? Absolute maximum. As far as we know, we're not sure. From 2, 6 is the highest point, but it's omitted. So we're just going to say none. Okay? Absolute minimum, we do have. So our absolute minimum is 1, 3. So we're going to say x is 1 at 3, or f of 1 is equal to 3. Good. All right, let's do C. For C, local maximum, remember, it has to come up and go back down. That goes up, it doesn't come back down. That's omitted, so there is none. Local min, it has to be a valley, so it has to go down and immediately come back up at one point. So it's, again, none. Okay? Absolute maximum. The very highest point is 6, 3. X equals 6 at 3. F of 6 equals 3. Absolute minimum. There is an entire constant at what looks like y is equal to 1/2 or 1 maybe. So there is no minimum that is lower than any other point. So we were going to say none. So for C, it's none, none, none. There is one absolute maximum. That's it. Okay. D. Is there a local maximum? There is none because there is no hill. Local min. There is no valley, so there's none. Absolute maximum, there is. Even though that arrow goes down forever, it means forever in that direction. So it's never going to get higher than 0, 6. So we're going to say absolute max is x equals 0 at 6. Okay, that would be f of 0 equals 6. And then absolute minimum, none. It goes down forever. It doesn't mean you need to use infinity. It's just there is no absolute minimum. Oh, I was keeping the color scheme okay. All right, E, local max. Again, it needs to be a hill. That's a hill, but that's omitted, so we're saying none. This entire page has just been most of the time you just watching me write local max and local min. Local minimum, 2, 2 does not count because it's not a valley. So 5, 3. X equals 5 at 3. Absolute maximum. There's none because that is an arrow going up forever. Excuse me. Absolute minimum, there is again none because this is the lowest point, but it's omitted, so we don't know what the next lowest point would be. All right, and so that is how you do absolute max. Oh my gosh, I'm sorry, that whole time I was writing, you couldn't see me. So that's how you do absolute maximum, absolute minimum, local maximum, and local minimum. And I think that's the end of our lesson. Thank you guys, and see you next time.